Google Cloud's second core storage option is Cloud SQL. Cloud SQL offers fully managed relational databases, including MySQL, PostgreSQL, and SQL Server as a service. It's designed to hand off mundane but necessary and often time-consuming tasks to Google, like applying patches and updates, managing backups, and configuring replications, so your focus can be on building great applications. Cloud SQL doesn't require any software installation or maintenance. It can scale up to 128 processor cores, 864 gigabytes of RAM, and 64 terabytes of storage. It supports automatic replication scenarios, such as from a Cloud SQL primary instance, an external primary instance, and external MySQL instances. Cloud SQL supports managed backups, so backed up data is securely stored and accessible if a restore is required. The cost of an instance covers 7 backups. Cloud SQL encrypts customer data when on Google's internal networks and when stored in database tables, temporary files, and backups. And it includes a network firewall, which controls network access to each database instance. A benefit of Cloud SQL instances is that they're accessible by other Google Cloud services, and even external services. Cloud SQL can be used with App Engine using standard drivers like ConnectorJ for Java or MySQLDB for Python. Compute Engine instances can be authorized to access Cloud SQL instances and configure the Cloud SQL instance to be in the same zone as your virtual machine. Cloud SQL also supports other applications and tools that you might use, like SQL Workbench, Toad, and other external applications using standard MySQL drivers. The third core storage option offered by Google Cloud is Spanner. Spanner is a fully managed relational database service that scales horizontally, is strongly consistent, and speaks SQL. Battle-tested by Google's own mission-critical applications and services, Spanner is the service that powers Google's $80 billion business. Spanner is especially suited for applications that require a SQL relational database management system with joins and secondary indexes, built-in high availability, strong global consistency, and high numbers of input and output operations per second. We're talking tens of thousands of reads and writes per second or more. Google Cloud's fourth core storage option is Firestore. Firestore is a flexible, horizontally scalable, NoSQL cloud database for mobile, web, and server development. With Firestore, data is stored in documents and then organized into collections. Documents can contain complex nested objects in addition to subcollections. Firestore's NoSQL queries can then be used to retrieve individual specific documents or to retrieve all the documents in a collection that match your query parameters. Queries can include multiple chained filters and combine filtering and sorting options. They're also indexed by default, so query performance is proportional to the size of the result set, not the dataset. Firestore uses data synchronization to update data on any connected device. However, it's also designed to make simple, one-time fetch queries efficiently. It caches data that an app is actively using, so the app can write, read, listen to, and query data even if the device is offline. When the device comes back online, Firestore synchronizes any local changes back to Firestore. Firestore leverages Google Cloud's powerful infrastructure, automatic multi-region data replication, strong consistency guarantees, atomic batch operations, and real transaction support. The last of Google Cloud's core storage options we're going to explore is Bigtable. Bigtable is Google's NoSQL Big Data database service. It's the same database that powers many core Google services, including Search, Analytics, Maps, and Gmail. Bigtable is designed to handle massive workloads at consistent low latency and high throughput, so it's a great choice for both operational and analytical applications, including Internet of Things, user analytics, and financial data analysis. When deciding which storage option is best, customers often choose Bigtable if they're working with more than 1 terabyte of semi-structured or structured data, data is fast with high throughput or it's rapidly changing, they're working with NoSQL data, This usually means transactions where strong relational semantics are not required. Data is a time series or has natural semantic ordering. They are working with big data running asynchronous batch or synchronous real-time processing on the data, or they're running machine learning algorithms on the data. Bigtable can interact with other Google Cloud services and third-party clients. Using APIs, data can be read from and written to Bigtable through a data service layer like managed VMs, the HBase REST server, or a Java server using the HBase client. Typically, this is used to serve data to applications, dashboards, and data services. Data can also be streamed in through a variety of popular stream processing frameworks like Dataflow Streaming, Spark Streaming, and Storm. And if streaming is not an option, data can also be read from and written to Bigtable through batch processes like Hadoop MapReduce, Dataflow, or Spark. Often, summarized or newly calculated data is written back to Bigtable or to a downstream database.